Hi, today we're going to be talking about functions and how to determine if a relation is a function based on looking at a table or a mapping diagram or a list of points. So first of all, definition of a function. A function is a relationship between a set of inputs and a set of permissible outputs with the property that each input is related to exactly one output. Now, the kind of standard in math usually is for your input to be x and your output is your y. Right, especially if we're graphing on the xy coordinate plane, that's always an input of an x value and output of y. So let's consider these two tables and determine if any of them represent a function. So see here, the input of 0 would be an output of 5, that's fine. Input 1, output 6, input 2, output 8, okay? Now input 3, output 5. Now question to consider, is this a problem that these two 5s are the same? Well, each input, 3, only has one output, so that's okay. You can repeat the outputs, that's no problem. 4 goes to 10. This is still a function, yes, because every input has exactly one output. Outputs can repeat, that doesn't matter. But if we look over at this table, in contrast, notice that I have 0 goes to 1, 1 goes to 2, 2 goes to 3, 3 goes to 4. Wait, I see 2 again. So the way you got to think about a function is if I'm putting in something, right? If I input the value of 2, right? I should always get out the same thing. So for this function over here, or well, it's not a function. If I input 2, I'd be like, well, what am I going to get? Am I going to get a 3 or am I going to get a 5? I don't know. So that's why in this case, we don't know. So it is not a function. Okay? So over here, every input has one output. Another way to think about this is the x does not repeat. So this is a function. Yay! So now because it's a function, instead of the y here, you could leave it as a y, but sometimes you'll see the notation f of x to represent a function. So another way we could basically describe this table, function notation, is if you say f of 0 equals 5. That basically means you input the 0, you get out the 5. So in the same way, f of 1 equals 6, f of 2 equals 8, f of 3 equals 5, and f of 4 equals 10. See? Now there's a few different ways you can express relations that you might see, especially if you're trying to determine if something is a function. So you also might see mapping diagrams that look kind of like this. So if we were to do a mapping diagram of table 1, you put all your inputs over here. So you do inputs, you do outputs. Now we're not going to repeat the 5 because you only need every output listed once. And so how we draw this, the 0 goes to 5, the 1 goes to 6, 2 goes to 8, 3 goes back to this 5, and 4 goes to 10. So if you're looking at a mapping diagram, you're trying to determine a function. As long as the inputs always have one arrow going out, that's fine. If we go over here to table 2, if we made that, 0, 1, 2, 3 are the only things that are valid inputs. The valid outputs, you've got 1, 2, 3, 4, 5. So as we're mapping this, you see everything's going pretty nicely until here. The 2 also has an output to go to 5. If I have, again, this spot right here, that tells us that it is not a function. Now, the last thing I want to mention, sometimes you see these as a list of points. Now, in these tables, we're assuming it's not a continuous function. Let's say this table defines what the entire function is. There's discrete functions, and there's also continuous function. So if this is a discrete function, the other way you could list this is with a list of numbers, basically. So I could go to this and I could list the point 0, 5, and I'm going to put it in a big set. If you're familiar with set notation, this brackets could represent a set, and you could have a set of ordered pairs. So a set of ordered pairs is a function, again, if every input or if every x value has exactly one output. So that, you could look at this and just consider, okay, in other words, my x doesn't repeat. All my x's only show up once. They don't repeat and have a different output. Where this one over here, I'll go ahead and show you the list of points that corresponds to this, but then kind of break down how that happened. So this one, again, the point 0, 1, because the 0 goes to this 1, 1, 2, because this 1 goes to this 2, 2, 3, because this goes here, then 3, 4, because this 3 goes to that 4, and then this last point here, 2, 5, again, it's because of this 1, 2, 5. But again, just like how I showed that, again, this one input having 2 arrows coming out of it, imagine for a second that all you had was this table and somebody asked you, I mean, all you had was this list of points, and somebody asked you, hey, is that list of points represent a function? You'd say, let's see, 2, 3, and 2, 5 are on the same list. No, it cannot work. Again, so it's not a function because the input is repeating with a different output. So hopefully now, no matter the form you see, whether you see a table, a mapping diagram, or a list of points, you could determine, is it a function or not.